Well, good evening, everybody. This is meteorologist Andrew Pinero with this live weather update where we have a snowstorm brewing. So, Raymond, Delvin, thank you for joining. Yes, it has been some crazy weather. Texas A&M, some tornadoes. Raymond, I know you and I talked about it earlier. The confirmed EF2 tornado in Jersey. Snow in Massachusetts tomorrow yet because the time, at least timing wise, that's when going through Massachusetts it'll be. It won't be overnight tonight like it will be for the tri-state region. It'll be tomorrow for Massachusetts. So, how is everybody doing? Getting things all set up here. Looks like we are good to go. Yes, we do have one Friday. However, we will not be talking about this one. When it comes to these major storms, usually I like to handle them at least one at a time. So I'm going live tonight to talk about the storm overnight tonight and tomorrow. And then tomorrow for the usual Games and Storms live stream, that's when we'll talk about the week ahead, including that next storm. Usually I've always said February is the snowiest month, and climatologically that seems to be the case, where February is usually the snowiest month, and it waited to the very last day, but at least it's going to be, it looks like this year, the snowiest month potentially of this season, 2022 to 2023. All right, so let's, there we go. Let's get started here. Okay. Make sure everything looks good here. And yep, it does. Awesome. Yes, the radar you were talking about. Let me see if I can bring that up now. So that was on the Albany radar. Not showing it, it looks like. Oh, so I don't think you were in the precipitation depiction. Not showing it now, but it is showing these beams, which I believe was also part of what you were seeing with the one that extended all the way from Albany down to Cape May, kind of. That one beam. I don't know what it is around the Albany radar. However, with this, the OKX radar in Upton, that one beam, like gap right there, is because of a building that is right next to or near the radar tower. It was positioned in such a horrible spot. So here's the radar tower, say right in the middle there, where there's the dome. Can't see anything inside of the dome. But once you get there, there's a building right there that's blocking the view, and kind of the way perspective goes, when you start small and you go out, it's kind of like a triangle or a cone with these vanishing points. That's kind of, even though it's more of an art than design kind of idea, it's affecting the radar here. It's a very thin cone, but you can see it starts very thin at the radar and it expands just a little bit as it gets from Long Island to Binghamton. But anyway, take a look at that radar. Let me actually, since most of this is south of the tri-state in Jersey, that's quite intense right in here. So I've switched to the Mount Holly one. No, Raymond, that's not. Well, for the one from Albany, maybe, but the one from Upton, OKX, it doesn't cross anywhere near the tri-state. Sorry, the New York City area. Is that what you meant? Yeah, we did. Oh, let me switch back here. Cool. So let's put this in motion and let's take a look at what we got out there right now. There was that one little bit that came through earlier, and here comes a little bit more of the heavy stuff. And for the most part, I believe is snow. So it's showing mostly snow up here through kind of the New York City area with a little flickering back and forth between snow and that sleet. I don't think it really turned to really rain in there, but I've always been told there's no such thing as Central Jersey, but I'm going to call it is. I got yelled at by they because they said there's no such thing as Central Jersey. There's North Jersey and South Jersey. I'm getting yelled at by everybody from Jersey. You can't trust those Jerseyans, even if you marry one. Being corrected. Sorry. Anyway, okay, so I call this Central Jersey, and that's what I'm sticking to. Yeah. So Central Jersey, that's where, let me stop the radar. That's where we're kind of seeing the transition point between the snow and rain and sleet. There is the radar right now showing this one little peak. I don't think that is entirely correct because, again, this is just a computer simulation. And if you go back just a few slides, there we go. It jumps a little bit here and there. I'm not saying it can't be happening, but I think most of this is snow with a little sleet in there, not really any rain. And the rain, we'll really say, is between Middletown, Trenton kind of area there, and south. That's really where the rain's going to be. Raymond thought our conversation was funny. All right, so that's what's going on there. Let's try and take a bigger look at the radar here. Where'd you go, radar? There we go. So this is quite a big system. It's basically spanning from, I kind of would relate this, so Wisconsin, Minnesota, all the way through Maine. So quite a widespread system. When we zoom in here, we can see the multiple rounds. So round one was that outer band already through the tri-state region that will be making its way through into Massachusetts and Boston very shortly. Radar scope can do that as well. I just don't usually turn those on. I don't remember where that was. I always get confused where the settings are versus the preferences. Apparently settings and preferences are different. Here we go. TDWRs. So that it just turned on. And here, Newark. So this is where you get a little bit closer of the radar. So Newark, JFK. You see they are smaller. They're not as encompassing as the National Weather Service radars. Does it not have the precipitation depiction? I've never really used the airport ones too much before. Oh, there's a long range. Cool. Velocity, storm totals. Not really showing too much of what I would like. Switch back there. Anyway. So it does have that ability to show the airports, the airport radars. All right, so it is snowy outside. Last time I looked, it was just starting to stick. It didn't accumulate just yet. But you always have to have this melting layer first. If it's not like sub-freezing temperatures, which right now it's 34. So it was in the upper 30s to the mid 30s not too long ago. So the snow has to make contact with the ground and it has to melt, which requires, I forgot what exactly it's called, but it's a transfer of heat. So when the cold snow melts on the ground, it pulls heat out of the ground, therefore cooling the ground. And then when enough of the snow comes down, it cools the ground enough to the freezing point or sub-freezing. Usually it sticks right around the freezing point. And once it's there, any further snow on top of that will just stick, and that's when the accumulation starts. So on the bigger radar here, that system is affecting us. There's a gap in the middle. And then we won't even really talk about it, but all the historic snow that happened in California, they have had quite a weather week as well. We're just going to kind of stick here. So kind of what I was saying before, we have this one outer band that made its way through the tri-state region. We'll be entering Massachusetts, Boston area shortly. Then we have the band coming through right now. Let me pause this. And this is where a lot of the snow is going to be coming from. And then we have this final band that's going to be coming through more overnight tonight. And that's the final one that's going to give the last bulk of the snow. That's also where it's a question mark of where the rain snow line is going to be. Are we going to see 1 to 3 inches? Or are we going to see maybe 8 inches of snow? All right. So here we go. Water vapor. So this is also one thing I like to take a look at as well. The water vapor imagery. Let's actually get a closer look. And let's give that a pause. Cool. So we do have a lot of moisture. There's not really a lot. Actually, that's a little too zoomed in. There we go. That's a bit better. There's not a lot of dry air in here. At least with the band coming through right now. There is, if you kind of think of this in terms of a regular like synoptic scale system, usually we have this dry slotting that we can see. That dry slotting looks like it's starting. If this is the center of the rotation, it's pulling in a little bit of this dry air, but that's not really enough to snuff it out. So I would say we don't really have that to be concerned about. I'm going to put this back in motion here. We can really see the spin is not that great, but there's a lot of moisture ahead of the rotation. And that's kind of what we're seeing here. This looks like it's a double low pressure. 2 low pressures connected by an occluded front. However, I would kind of consider this one big system. And it may not be the fastest mover. That's why even though it's not a mass encompassing storm, it's a fairly large storm. But because it's not the fastest moving, that's why it's going to be like dumping snow. Yes, and there's another, Raymond, you're correct with that. There's another phenomena specific for the Hudson Valley, or really any valley. So let me get back on the main camera here. All right, so this phenomenon, I forgot what it's called. Essentially, you have the Hudson Valley, and there's this little mountain region. And then you have the ocean, the Atlantic Ocean, that has a lot of calming or subsidence, sinking motion, usually a stabilizing effect. And that can kind of get trapped by the mountain regions. So any snow, any convection, anything like that can kind of be glanced. It heads up to the ridges of the valley. And because of the denser air in the valley, it can't really break through that denser air. So it can go up and over and kind of like air hockey, you could think of it as. You have this denser air, really just fast moving air for air hockey. But in our example, it's denser air. And it provides almost a frictionless surface that the weather kind of just glides over the top of that. So that's something that can be affected, and that's going not just on a mesoscale, that could be more on the micro scale. The micro scale is actually a scale that the bigger GFS model or the European model can't see. It can't see those in-between events. All right. So that is something to be concerned with. And what you're talking about with the downsloping, yes, that is also something to be concerned with too. Because when you have differentiating temperatures, and essentially it's all related to density. As it goes up one side of the slope, or up one side of the mountain and down the other, it can dry out the air. That's why when you think of the Rockies, the windward side, when we have storm systems moving from west to east, very moist. That's the kind of California area. Then once you go past the Rockies, east of there, it becomes a bit more of a drier desert environment. Okay. Moving right along. All right, now let's get into some of the meat and potatoes of this. Wow. I said that, and there's an ad for meat. While we're in the meat and potatoes. That is kind of weird. Meat and potatoes and meat appears. Yes, very interesting. Okay. So, starting with the GFS on a good old tropical tidbits here. It looks like as of, so this is the initialized 0Z, yep. Do you agree with having two sources of radar? Or not really? What do you mean by two sources of radar? Or you mean like having, say, radar scope and the radar Omega you're talking about? Like two different apps? All right, so let me take a look here. There's that low, 989. So a decent low. That's causing on the front side here pressure gradient. Okay. It depends. Two different apps they may actually show different things, or the layout may be different. Usually I would say stick to one and really get comfortable with one instead of going back and forth between a couple different ones. But in terms of, say, having radar scope and the National Weather Service radar, yeah, I would have both. The difference is radar scope is a single point radar. So this is where I would have two different types of radar, not two different radar apps. So again, this is single point radar. I have to select the radar point. So I select one and it shows me the radar there. Versus, I go back to here, the National Weather Service radar. This is not a single point. This is a radar mosaic, which is a composite of all of the radar stations. That I would say have both. Okay. So here's the bulk of the storm. So this is 6Z Tuesday, which is 1 a.m. Eastern Standard Time. And right there's the freezing line. Now, computers like polygons. So this is making a straight 90-degree line of the freezing line. We know that's not going to happen. But we can kind of generalize around this area, around New York City, is going to be the freezing point. So anywhere around there is going to be very wet, heavy snow. North of there, it's going to get colder, but with less moisture. So less snow, but it'll be that more drier, powdery snow. South will be rain and sleet. And then by Tuesday morning, looks like through the New York City tri-state region, it still stays cold. So this looks like it could be an all-snow event for areas like Sussex County or North New Jersey, the Hudson Valley there. Yes, he is probably referring to what I was talking about with also not different apps. So Radar Omega and Radar Scope, they're two separate apps, two separate companies, but they actually can pull the same radar data. If they're pulling the same radar data, the only difference between the app is the user interface. That's where you have to check the source where it's pulling from. If they're both pulling from the same source, then it's kind of redundant. Where was that? And I can show you that here. Where is that? Oh, that was back in settings. So here, radar data. I can choose, the radar scope, normal, NOAA, Allison House, and Allison House is big with the Storm Chaser community. I don't have a paid subscription to that. Amazon. I didn't know Amazon was here. Interesting. So this radar data that says radar scope, very interesting here that it doesn't really specify where they're getting their radar data. Keep that on. Okay. Yeah, so this is where you can choose the data. So again, like with lightning data, I don't have Allison House. I have the Radar Scope Pro. Warnings. That's interesting. That allowed Allison House, but I'm going to keep that as Radar Scope. I don't have a paid subscription to Allison House. That's where you have to check the source data. Okay. And there we go. There. Now that I changed the radar source from Allison House to Radar Scope, I get storm tracks again. I was wondering why I wasn't getting any. And back to here. So this looks like it's going to be a short-lived storm. It's not going to be multiple days. It is still kind of a slow mover. Yeah, and Allison House I've never used before. Because I pay for Radar Scope, I decided just not to also pay for Allison House. All right, and we'll get the snow totals later, but just want to show you it's a fairly short storm, but it's slow in the parts that count. And then by Tuesday afternoon, there for Boston is very close. And that's going to be either heavy snow or heavy rain. Right around there. All right. Switching the pivotal weather for the Euro. So this here, just starting at 0Z. So this would be 7 p.m. It is past that now. Oh, Allison House warnings. Oh, interesting. Yeah, I never knew that they include it free when you have the radar scope. The Euro shows a little bit more accurate from what I would say, instead of a straight line of the freezing line, kind of a wiggly line, which is more accurate. Because air is a fluid and it has waves. But for that period around 1 a.m., it's showing pretty intense snow. And then it's really out by 7 a.m. in tri-state. Then it's into the Massachusetts, Boston area. Turns actually, this one's showing to ice and then out by Tuesday evening. And then Wednesday looks like a clear day. Pulling out all the stops here. So we're going to the icon next. Rewind that. There we go. Okay, so this is showing now 3Z is where most of it is happening. So by 10 o'clock, we should be starting to see a bit more intense snow. And then the freezing line on the icon here stays fairly consistent. Interesting. Yeah. So I would say stick with what you use. And so it looks like that freezing line kind of stays fairly stable. That's where right over New York City could do that transition back and forth. But north of New York City, it looks like it's to be all snow. All right. The NAM, rewind that. Oh, this is model run in progress. So this is the 0Z run. It might not, it's only going out 20 hours. That might just be enough. So let's see. All right. So that is 8 p.m. It hasn't started yet. And now this is reflectivity, which I think was a little on the slower side. Ah, yes, Raymond on the same way. That's why I like radar scope. I like to prefer and stick with radar scope. Okay, so in here goes out just enough. Cool. And it actually looks like for most of this, the freezing line stays pretty stationary. That's some intense snow in some areas there. And this is actually where it looks like the southern part of the Hudson Valley. So Rockland County, Westchester, Southern Orange, and Southern Putnam could get more snow than up north, which usually Sullivan, Ulster, Dutchess get the most. And then this lasts through Tuesday morning. Actually, it sticks around a little longer until Tuesday afternoon. And this actually shows what looks like a little bit more clearly with the counterclockwise flow of the low. It's pulling in moisture from the ocean and kind of flinging it onto the coast. And then it's out by Tuesday evening from the tri-state region, but it's still coming down pretty moderately in the Massachusetts and Boston area specifically. That was the 12-kilometer NAM. Now the 3-kilometer NAM. This model run, also the 0Z, is still in progress, only 15 hours out. Let's see. Wow, the 3-kilometer NAM is very intense. So this is showing 10 p.m. is when the heavy snow starts, and it stays pretty much like that until, let's say, probably 7 or 8 Z. That's pretty intense. And also, it can be more accurate because the 3-kilometer NAM is a more higher resolution model than the 12-kilometer NAM and the Euro, because those are bigger pixels. You make the pixel smaller, like on a television, you make or any kind of screen, you make the pixel smaller, you increase the resolution. Yes, Delvin, you actually bring up quite an interesting point. That because of the time frame we're in, that sunsets are 5:30. The freezing line is, or the time for sunset is still early enough that any kind of nighttime snow event is going to be colder. Yeah, because this is now kind of late season going into March for winter. Yes, Raymond, you are correct. And that's when I was working at the news station. I learned that. So that was 7 years ago? Wow. Okay. So 7 years ago, that's when I first learned that using just the standard snow totals are not the best, because that always assumes that 10-to-1 ratio. The 10-to-1 snow rain ratio is not always accurate. So the total positive snow depth change takes into account the forecast model's forecast for the snow ratio, which usually when it's warmer, the snow ratio drops. So if it's snowing above the freezing point, usually that might be, say, an 8-to-1 or a 6-to-1 ratio, meaning 1 inch of liquid rain would be equivalent to, say, 6 or 8 inches of snow. If it's cold, if we're like at 15 degrees and we get this same amount of snow, then that snow ratio of 1 inch of rain would equate to, say, 15 inches of snow, because it's colder and it's drier. Oh, look at that. It's popping in hours right now. Live data coming in right this moment. All right, so the 3 kilometer dam's pretty intense for most of this. The freezing line, again, stays fairly consistent there. A little wavy, but that we can expect. And let's see, so that goes out now to 20Z tomorrow. And it's still showing some pretty intense snow. Turning it a little bit into rain. For anywhere around that Cape Cod area. Okay, so that's the 3 kilometer now. And now the good old HRRR. So this only goes 6 hours out. 1Z, let's just go back to the 0Z. There we go. Now we have the amount that I would need. All right, so this is already initializing fairly accurately. So 1Z, it's the first initialized frame. You have near blizzard conditions in your area. You know what the wind speed is? Oh, I actually don't have that open. This was one I learned. It was 2023. So I learned this 11 years ago. Hint.fm/wind. This is a wind map of the entire country. And when we zoom in here, we can see the rotation where the low pressure system is. Also here, you could see boundaries, so we could see where fronts would be. It hasn't caught up just yet. There we go. I'm a little bit east of where I was. There we go. What is this? Oh, this is 8:29. So actually, this isn't fully updated. So this is about a half hour behind. So it's probably, I'm guessing, Raymond, about a half hour ago, you were not seeing any blizzard conditions. But that's where I'm guessing a lot of this wind here. Top speed 41 miles per hour. And even going into here, these 15 to 30 range, that's kind of where this is, I would say. So yeah, that's where I think that stronger wind actually came through into the Albany region. So yeah, you could be seeing that. Let's see what I have. What's the current wind speed? So I'm not sure if you heard that, but it said 9 miles per hour, east-southeast, which is kind of what we're seeing with the wind map here. Where were we? Oh, not there yet. We're on the HRRR. There we go. So this is showing something fairly similar where the freezing line stays fairly level. But the HRRR is also not nearly as intense as the 3 kilometer NAM. Again, let me wind that back. Look how intense that is. And going back here. Heavy wet snow, yeah. So that makes sense because the temperature hasn't dropped enough just yet. It's all probably near the freezing point. Even if it's still like a degree or two below freezing, I would expect that to still be wet snow. Because it's coming from, or the temperatures aren't falling that rapidly. Actually, before we continue, I'm going to go take a quick observation outside, and I will report back to all of you as well. So, Raymond, thank you for your report. And there we go. Thank you for your report, Raymond, and I will gather a report as well. Oh, hang on. I lost my music slide. Gotta make sure I have the correct type of music for the YouTubes. If it wants to load, there we go. Don't remember what I had before. Let's just bring up some good old 80s. All right. I will see you in a couple of minutes. All right, I am back, and I bring presents. Right. Switch on back. Cool. So, report. The wind isn't blizzard at the moment. I would definitely call this near blizzard or blizzard-like conditions. Visibility is most definitely less than a quarter mile by me right now. The wind, I would probably say, is sustained around 10 to 20 miles per hour. It's not snowing sideways. It's more snowing diagonal at the moment. So it's not blizzard-like, or I would say it's kind of blizzard-like, but it's definitely not blizzard conditions. We'll get right back to that. Yes, our daily NOAA weather radio alert. Actually, before that, because I did bring something that is very time sensitive, I brought snow with me. So let me see if I can get that in focus here. Where are you? Where's the focus? There we go. Cool. It's correct. Yes. There we go. All right. So I brought some snow in here. So this is definitely that wet, heavy snow that compacts very easily. Some snow on my keyboard, but it compacts very easily there. So this is very good snowball making snow. Okay, actually make a snowball, a mini snowball. There we go. So there's a little mini snowball. All right, keep it in focus for you. So this is very wet snow, which makes sense. Also, the pattern's not helping on the cup there. It was the clearest cup I had. And there we go. Cool. And we are good with the keyboard. So that is some wet snow. And the fact I already have at least an inch that's on the ground. I am just outside the New York City area. So I would say if this started, I feel like this started around 7:30. Go away, Siri. So in about an hour and a half to an hour, this was about an inch an hour. Just under, I would say, an inch an hour. Yeah, so it's about an hour and a half, I got an inch. And it's only going to get more intense, too. Also, the drink of the night is just Pepsi Zero. Usually I have Coke and not Pepsi, but I got some Pepsi because they didn't have what I wanted. Okay, now, Raymond, it is time for weather radio tuning. For those of you that are watching and you don't have what we call a weather radio, this is something very important to have. And I have one here, and let me try and do the focus thing again. There we go. So this is the radio I have. It is not a dedicated, there we go. It's not a dedicated weather radio. This specifically is what is called a GMRS radio. So basically this is a beefier version of a regular walkie-talkie that you can get from Walmart or Amazon or something like that. But this, once I turn it on, wrong button, there we go. This has channels that you can tune to. And then there's a button I hit here. And now that is listening to the NOAA weather radio frequency for my area.
Very difficult. The hazardous conditions could impact the morning or evening commute. Additional details, snowfall rates should reach around 1 inch per hour tonight. The highest snowfall totals should be at locations above 1,500 feet in elevation. Some sleet and freezing rain is also likely.
So it doesn't sound the best at the moment. That's also because we're mostly interior right now.
Total snow accumulations of 3 to 5 inches. Where? Portions of northeast New Jersey and southeast New York. When? Until impacts. Plan on slippery road conditions. The hazardous conditions will impact the Tuesday morning commute. Winter weather advisory remains in effect until 1 p.m. Tuesday.
So that was the NOAA weather radio. Let me just turn that off for the moment. So these are always good because you can't completely rely on the internet to be functioning in weather events. Let me just readjust focus. Cool. So you can't completely rely on your phone to give you weather alerts, just because if the cell network goes down or your internet goes down, you have no good cell service, you may not get that. But what's nice with the NOAA weather radios is it's broadcast from a central location, and it doesn't rely on an infrastructure. The signal's just broadcast out, and it's just in the airwaves for you to receive. That's what's nice with the NOAA weather radio. You don't have to get a handheld one like this. I have this so that you can use this as a handheld walkie-talkie. But you can get a little base station one that might be like $50 or something like that, that just sits plugged in. You just turn on. It can scan through and detect what the actual weather radio frequency is for you. And it will tune to that. Cool. I don't know why this always gets behind when I watch this back. One of my playbacks. Okay. That's better. All right, so bringing back here to the forecast models, the HRRR. So the HRRR, even though it's the highest resolution at 1 kilometer, not always the most accurate. But especially mesoscale and even like the microscale event, it can be because it can see those better at 1 kilometer resolution. All right, now let's switch to some snow maps. Very good point as well, Raymond. If you live in an area that has a lot of tornadoes and you have tornado sirens, I know there are no tornado, even though there's a tornado in Jersey and it happens here, we don't have tornado sirens. You know what we have? We have nuclear fallout sirens. Huh? Meg said those are more important, which I don't know. I would say they're both pretty important for both of them. Tornado siren and a nuclear fallout siren. Because I live, I think, within 10 miles of a nuclear power plant. So if there is a nuclear meltdown, we have nuclear fallout sirens. Is it fallout? I don't know the exact term. And yes, it didn't happen on the HRRR, so it's not always the most accurate. And I don't know how I trust the 3 kilometer NAM either. Also, it's slightly different. It's not simulated radar. It's not 3-hour accumulations. This is instantaneous precip rate in millimeters per hour. So what this is saying right here, if I put the crosshair right there, that dark blue for snow, that is saying we are, that's actually not too far off from what we're seeing. So going into that dark blue, let's say 5 to 6 let's say 5 millimeters of snow per hour. Now 2.5 millimeters. Oh no, that's centimeters. Never mind. I got my millimeters and centimeters mixed up. So that's saying 6 millimeters. Oh, it doesn't say if it's liquid. Oh no, it can't. It's not liquid because it adjusts for snow. I'm guessing right here. So let's say that's 6 millimeters of snow per hour. So that would be half a centimeter of snow in an hour, which would be 2.5. Half of that would be 1.25. About 1 centimeter an hour. So it's still less than an inch an hour. But it's still pretty intense there. All right, now to the snow total maps. One quick peek there. Okay, now to the snow total maps. The GFS. Here we go. Bada bing, bada boom. By the end of this system, and we're not going to add in the next system because, again, this is a total snow depth, total positive snow depth change. So it's basically not resetting anything. All right, so here, it's actually kind of showing this spine going from north of northern Hudson Valley through through Albany. I would call this 6 to 10 inches there. Ah, interesting. I'm not sure about that. Delvin, do you know if there's any part near you of Massachusetts that has tornado sirens? In the Hudson Valley, looks like we're in a 6. Actually, yeah, 6 to 8, I'd say, and then we're starting to get into that 9, 10 region in there. No idea. Okay. New York City is right on the cusp of the freezing line, so there's not much happening there. So that is the GFS. Now we're gonna look at the gem. Hey, we don't bring it out. We don't bring this out too often, but when I do, you know it's intense. So here, it's actually not out of the realm of possibility. I think it's a little bit more west than what's gonna happen with this line. So when you look at here, that intense line of snow is basically. I go from the tip of Manhattan straight north to say Battery Park in Manhattan right there. Straight north. It's kind of in line right there. But when I switch to the Canadian one, if I go that same point, the tip of Manhattan, which is kind of right about there, straight north, there's not much happening there. It's more just a little bit west of that. I think it's actually going to be a little bit more east because the amount of moisture coming through is, I don't know. I would probably say this is a little, just slightly west, but not out of the realm of possibility. Okay. Moving on to the icon now. Icon's undercutting it. Let's go back to the icon here. I think I said that before. Yeah, the icon wasn't as intense with the snow there, and it actually was a little bit more north. You know, freezing line, it was kind of in there, but it just wasn't as intense as the others. The icon, I think's underplaying it a little bit. And now here. 12-kilometer NAM. And here we go. So this is showing, even getting down into a lot of North New Jersey. That's 6 inches or more of snow. It's showing for Rockland County. It's showing for Rockland County 9 inches of snow. That, I think, is a little much. I don't think it's going to be that much from the NAM. All right, so we're kind of balancing, kind of taking an average of all of these. Now the 3-kilometer NAM. Here we go. This is also, you can see, a little bit more accurate. Not accurate, I should say. Higher resolution. Because if we look at this one county right here, this is Orange County. It's showing 8 inches at the border of Orange and Rockland County. And then it has a little gap in here. And then it shows more pinks going into northern Orange County. Same thing for Ulster County. We have a couple of spots of green in there. Because this is higher resolution, it's showing a little bit more detail. Interesting, Raymond. So where I am, it was complete, at least an inch coating everywhere. Roads coated completely, sidewalks, cars, everything's been coated. All right, so that's what the NAM is saying. Oh, actually, let me do one other quick thing here. Here we go. 1 second. I want to send this to one person. Okay, that is sent away. Back to the models. So this, I would say, is maybe a slight bit on the higher side in some areas. But for most of the area, I would say, yeah, it's going to be this kind of little patchy where one town might get 8 or 10 inches and the next town might only get 3. That's the 3-kilometer NAM. Let's take a look at the HRRR now. And even the HRRR is saying at least 6 inches here for the Hudson Valley. It's pointing out at the highest there looks like 8 inches. So we could see 8 inches in, say, Rockland, Orange County there, And even some areas of Westchester could see up to that 8-inch mark. And then usually when I'm starting to make a snow map, usually I want to kind of keep it in line with these ranges. Because you don't want overlapping ranges. For instance, you don't want 1 to 3 in one spot, then 2 to 4 in another spot, because you have this overlap of it's going to be 2 in one spot, but then 3 in another, and they overlap. So usually I would like to say 1 to 2, 2 to 4, 4 to 6, 6 to 12, or something like that. Or it would be 1 to 3, 3 to 6, 6 to 8, 8 to 12, something like that. So there's no overlap in the map. So here it looks like some areas in the Hudson Valley can be getting, I might actually say 6 to 10 inches of snow. And that's temperature. We're not there yet. Just running back through the snow totals here. So this was the GFS. This says the bulk of the snow a bit more north. However, the Hudson Valley was still showing that 6 inches there. Okay. The Canadian, 5 to 7, right in there. The Icon, which again we saw as one of the lower amounts, which we see in line with the snow totals, but the areas that are the highest snow totals are still kind of in line here. If we take that point at Battery Park in Manhattan and go straight north, it's kind of falling right in line there with those heavier spots. So although I think it's getting the correct layout, it's too low on the snow total map. Because already we are at 1 inch in Rockland County here. So if this is saying that the total for the storm is 3 inches, and we still have all tonight to go, I don't think that's correct. Here, 9 inches on the NAM. I think that is, let's see here. We have this little gap about to come through. This little gap's coming through there, and then we have more coming through, but that freezing line is still pretty far south. And again, all the forecast models were kind of showing it's hovering. If you go right over New York City, due west and due east, and you actually draw here. So we're going to draw a straight line through here. That is going to be the freezing line. So anything really north of this area, of this line I just drew right there, is snow. And then here we're going to have snow to rain. So everything's starting as snow except for very far south in Jersey. So that's where here, below that line I just drew, we're going to see snow. Oh, forgot to bring that back. What game will I play tomorrow night? I actually might be playing the new Harry Potter game. As long as I can get the capture from the PS5 correct, I'm probably going to be playing the new Harry Potter game called Hogwarts Legacy. I've been playing it, and it's really fun. So they have a broad 5 to 10 inches with no overlapping. That's playing it safe. Now, there's a balance you always want to strike between playing it safe and being too accurate that if something changes, then you're told by the public you're wrong. So some of the, and when I first started at the new station, I was drawing some of these snow maps. I was doing like 1 to 2 inches, 2 to 4 inches, 4 to 6 inches. I was doing these intervals every 2 inches. And the chief meteorologist said, "Great, I'm glad you have that confidence. However, if you're wrong by an inch or two, if you're just an inch or two, it's not a lot, you're going to be chewed out by the viewers." I was like, okay. He just said, just to cover your ass, make it a broader range. So instead of 1 to 2, 2 to 4, 4 to 6, start at 1 to 2. That could be fine. Then you would go 2 to 6 potentially, or 2 to 4. Then you go 6 to 12. Then you go 12 to 24. So you see, as the snow totals get bigger, the interval gets bigger. Or you might even do, say, a 1 to 3, and then 3 to 6, and then 6 to 12, 12 to 18, or 12 to 24 to encompass anything, or just say 12 plus. A lot of news stations I've seen do that. They have, especially the past couple of days when it was a little bit dicey what exactly it was going to be. It was 3 to 6 plus, or say 4 to 8 plus. That high end, not everybody was too certain of. I'm fairly certain now with the high end that we're going to see in the Hudson Valley, I'm probably going to say 6 to 10 inches of snow. Yes, Delvin, I get what you're saying now, and I do like that. However, the intervals, the 6 to 9 interval, usually not. Because this is also going into a subconscious thing of, for some reason, the average viewer doesn't like numbers like that. So you usually want to stick with even numbers. Yes, this is getting less into weather forecasting and more into human psychology, but when you're dealing with the public, you have to deal a little bit with human psychology. So, 1 to 2, 2 to 4, 4 to 6, fine. Or you can expand it just a little bit, 1 to 3, 3 to 6, 6 to 10, 10 to 16. Usually I wouldn't say 16 to 20. I would probably say 16 plus at that point. Unless I know it's getting into the 3 feet in some areas. So the intervals, yes, it's kind of like an exponential square or a log function, where the greater the snow totals get, the bigger the interval should be. Yes, Delvin, that is... Actually, I think that's exactly what I have. I have a drawing app called Procreate on my iPad. And you can hide layers and show layers. I think those are some of the presets I have. 1 to 3, 3 to 6, 6 to 12, 12 to 24, and then 24 plus. Yes. And that is the subconscious thing too. When do you switch from inches to feet? Because you could say 12 to 24, or you can say 1 to 2 feet. What sounds worse? Because news is negative. You always want to try and lead with the negative. That's just the way the news is. So what sounds worse? What's going to get the viewer to come in and watch the show? If I say 1 to 2 feet of snow, or if I say 12 to 24 inches? It kind of depends, but mostly the bigger the unit. So instead of the unit of inches, the unit would be feet. The bigger the unit, the bigger it sounds. So 12 to 24 inches sounds less than 1 to 2 feet. What do you two think of that? Yes, they would be doing centimeters and meters. And also the traces, they might even do millimeters. I don't know if they do millimeters, but yes. Yes, Delvin, you are correct. There is a unit between that. So that would be a decimeter. So a centimeter, century, 100. So a centimeter is 1/100th of a meter. A decimeter is 1/10 of a meter. So if you say 2 decimeters, that would be 20 centimeters. And then going the opposite way, a decimeter turns into a decameter. So a decameter would be 10 meters. A decimeter is 1/10 of a meter. Yeah, tens of meters versus tenths of meters. Raymond, but Delvin, you're right. So I actually don't know how they cover news like that or snow in Europe. But yes, decimeters would be pretty good. 1 inch equals 2.54, just 2.5 centimeters if you're just rounding to the 10th. 10 centimeters is 1 decimeter. And so 10 centimeters. So 10 divided by 2.5, you would kind of do to get the equivalent. Yep. 6 inches of snow would be 1.5 decimeters. 2 feet of snow would be 5 decimeters. Yeah. Yes. That's actually the benefit of the decimeter. You don't have to kind of switch between, if it's that shorter range, between a centimeter and a meter. That kind of covers the 10th of a meter. We started sciencing now. Okay. So this picture I have right here, that's saying, so anything north of this line is going to be really seeing all snow. South of this line, snow to rain. Right on that line might be a little bit of a sleet. Yes, numbers are fascinating because numbers don't lie. All right. So if I were to pick a particular model, where are you? I would probably do the 3 kilometer. The 3 kilometer NAM here. Because it's showing a bit more of this patchiness, which is good because the higher resolution shows a little bit more detail. Even it may not be a more accurate detail, but it could be more precise detail. And also going into sciencing and numbers that are fascinating, there's a difference between accuracy and precision. So the 3 kilometer NAM is a more precise model. Therefore, it's showing a little bit more detail, more precision. It may not be more accurate, though. So you can have a highly precise forecast model that is inaccurate. An example of that would be, this is where I learned the difference between accuracy and precision. A game of darts. So if you have somebody that hits near the bullseye, and they're always maybe an inch or two around the bullseye, they're fairly accurate, but they're not precise. Precise would be if somebody hits, say, the 3-point area every single time, and each dart's only about a half an inch away from each other. Very precise, but they're not as accurate as the other person. The other person's more accurate, but not as precise. Science education. Anyway, back to here. I would say this is kind of more in line with what I would do. So in here, this is probably where I would say 6 to 10 inches for most of the Hudson Valley. Going a bit more north, I would probably say that's that green. What's the green? The green's a 12. This is probably where I would say 10, maybe even 10 to 20 inches. The bulletin boards? Yes. All right. So if I had to, I'm gonna make my own snow totals map and draw that and post it on all the social medias. But for right now, let me take a screenshot of that. I'm assuming it took a screenshot of that. That is about what I'm gonna think is the closest to what's gonna happen with the snow. And we just focused right now an hour and a half on just tonight into tomorrow. Tomorrow night, when I do games and storms. Yeah. Yep. Like connect the dots between all of the points that the person you're trying to go after. Yeah, I know. Anyway, tomorrow night, actually, let me switch back here. There we go. All right, so tomorrow night, I am going my normal Games and Storms live stream. That I am going to be talking about the weather for the week ahead, including the next snow potential, which looks like Friday. But tonight, I really just want to spend a lot of time talking about this one storm because it could be a bit of a tricky storm. All right, so I'm going to end the live stream. And I'm now going to also do a little bit of prep, make sure everything's charged. So that, again, what I'm about to do, I would say everybody should be doing for their storm prep, which would be make sure everything's charged, fully charge your cell phones, fully charge any devices that you need. The NOAA weather radio, I'm going to make sure this is fully charged. Along with there's another radio I have that can do NOAA weather radio as well. I'm going to make sure they're all fully charged. Laptop's fully charged. The backup battery I have that can run, say, my refrigerator, I'm going to make sure that's fully charged. And everything really I'm going to keep powered off because some things can go into sleep. For instance, the PS5 I have in rest mode right now after I play some video games. I'm going to make sure that is off just in case we lose power. And did a shopping today, yes. It's too late now for storm prep, but I did a shopping at 9 a.m. this morning. Make sure any last minute things we had. Gotta have the bread and milk. I got the bread and milk and also some eggs. All right. So, Raymond, Delvin, it was a pleasure as always. Thank you both for joining. And anybody watching that is brand new, feel free to hit that subscribe button below and that little bell icon right next to that so you get notified when I go live like this, and I'll be going live tomorrow, or I upload a video. And that's pretty much it. Have a great rest of your night, everybody. Please stay safe throughout this whole thing, because it can be intense overnight, but if you're staying indoors, it should be okay. This is meteorologist Andrew Pinero. Again, have a great night. Stay safe. Stay safe tonight, going through tomorrow, and I will see you all in that next video.
living at night, windowless ride, feeling alive. Nothing in sight, forever in flight. Follow those lines, we'll make it this time. Blurry street lights, work as a guide to memories that we're making tonight. Oh yeah, we'll make it tonight. Yeah. I'll do anything that I feel like I wanna do. I'm living life like I got nothing left to prove. No end in sight, just always staying on the move. I'll go all night if that's just what I gotta do. Life's too short to care about what you can't afford. Memories are in what you explore, so just don't be ignored. Go ask for more, go ask for more. 'Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH, country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? 'Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH, country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? I'm in a race that everybody's chasing fast. They wanna be that someone on the screen at last. They ain't looking inside for their needs in life. They wanna be liked by everybody in sight. But trust me, being free ain't spotlights. No, it's long nights and it's long fights with yourself all the time to get your mind right. But if you put in the work, you can find the light, alright?